As more and more of us are driving EVs, this really weird, kind of low-tech problem is popping up: cable theft. And it's leaving people totally stranded. So yeah, let's dive into this because it's a way more interesting engineering puzzle than you might think. Seriously, can you imagine pulling up to a fast charger, your battery's on fumes, and the cable's just gone? Someone's literally cut it off and stolen it. This is happening, and it's happening a lot, all because of the copper inside. So the big question is, what in the world are we supposed to do about it?
And the first solution that pops into everyone's head seems so simple, right? I mean, we all carry a charging cable for our phone, so why can't we just have a big, powerful DC fast charging cable in the trunk? You just pull it out, plug it in, and boom, theft problem solved. It feels like a no-brainer.
Well, here's the thing. When you ask the engineers, you get a really interesting answer. They say, technically, yes. But then they follow it up with a big, but practically no. Just no. And there are some really solid reasons why. So let's get into the nitty-gritty of why that simple solution is actually a non-starter. And what's so fascinating is that the no isn't about some company wanting to sell you the proprietary thing or some boring standards committee. Nope, this all comes down to the cold, hard laws of physics: heat, weight, and just science. So let's put on our lab coats for a minute.
Okay, don't worry, we're not going to get too crazy here. It all boils down to one single simple formula that you probably remember from high school physics class. Power equals voltage times current. P equals V times I. That little equation, it's the key to this entire puzzle. It dictates literally everything about fast charging.
So let's put some real numbers on this to see the scale we're talking about. To get a 150 kilowatt charge, which is pretty standard fast charging, into a typical 400 volt EV, you have to shove 375 amps of current through that cable. 375 amps! That is a massive amount of electrical current. The best analogy is trying to force an entire raging river through a tiny garden hose. And that current, that I in the formula, is really the villain of our story here. And pushing that much current creates this cascade of engineering nightmares. It's not just one problem, it's a whole bunch of them. You've got the sheer size and weight of the cable itself, you have to actively cool it, we'll get to that. There are complex safety systems, tons of electronics, not to mention regulatory hoops, cost, liability. Each one of these is a total showstopper on its own. So here's the first big problem: heat. Anytime you push current through a wire, any wire, it generates heat because of resistance. It's just physics. But at 375 amps, we're not talking about your phone charger getting a little warm. We are talking about a colossal amount of heat. Enough heat to easily melt the plastic insulation right off the cable and, start a massive fire.
So you might be wondering, how do the cables at charging stations today not just melt into a puddle? Well, the answer is pretty wild. They have an entire liquid cooling system built right into them. Yeah, you heard that right. There are tiny pipes inside with coolant fluid being pumped through by, pumps and radiators, with sensors monitoring the whole thing. It's like a mini car radiator just for the cable, all designed to stop it from, melting.
And that right there, that's the heart of the problem for our bring your own cable idea. As soon as you add all that cooling hardware, the cable becomes an absolute beast. It's super heavy, it's thick, it's not flexible, it's not something you can just coil up and toss in your trunk. And on top of that, these things are wildly expensive. We're talking thousands of dollars. It's less of an accessory and more like a major piece of industrial equipment.
Okay, so if the portable cable idea is a bust, what's the real solution? Well, instead of trying to make the cable portable, the industry is focusing on the opposite, making the charging station itself a fortress. Basically, hardening the target so thieves can't get to the cable in the first place.
So you can see the shift in thinking here. Forget the user-carried cable. That's just too complex, too expensive, too heavy. The smart money is on practical deterrents, right there at the station. Things you can actually implement, like connectors that physically lock into the car or running the cables through what are basically armored pipes. Some even have these special reels that will blast an alarm if they're messed with.
Really, the strategy is kind of like a three-pronged attack. First, you lock it down. Make the cable physically hard to get to with things like armored conduits and alarms. Second, you make it not worth stealing. Maybe use different materials that have less scrap value or even hide tiny GPS trackers inside. And third, you make it risky for the thief. Flood the area with bright lights and put up very obvious CCTV cameras. Make them feel like they're being watched.
But hey, let's circle back to our original idea for just a second. Let's play a little thought experiment. Forget about cost for a minute. What is the absolute limit? What's the fastest charge you could theoretically get from a DC cable that you could actually carry around? One that doesn't have all that crazy liquid cooling.
this is a really important engineering question. Where's that line in the sand? At what point do heat and weight just make it physically impossible? Well, it turns out there's an actual answer. There's a number.
And that number is roughly 200 amps. Yeah, that seems to be the practical upper limit for continuous current in a cable that's still portable, still reasonably flexible and, safe to handle without a cooling system. You push much beyond 200 amps and you're right back to it being way too hot and way too heavy.
Okay, now this is where it gets really cool. Remember our formula? Power equals voltage times current? If we're capped at 200 amps, look what happens. With a 400-volt car, 200 amps gives you 80 kilowatts of power. Not bad, but with a newer 800-volt car, that same 200 amps gets you 160 kilowatts. You literally get double the charging speed from the exact same cable with the exact same amount of heat and weight. It's a total game changer.
And that, right there, is the single most important takeaway from all of this. The path to even faster charging in the future isn't about making ridiculously huge, hot, heavy cables to handle more current. The smarter way to do it is to build cars with higher voltage systems. That way you get way more power for the same manageable amount of current.
So this all leaves us with a pretty interesting question for the future, right? As we all demand faster and faster charging, the cables at these stations are only going to get more complex and more expensive. So, how fortified do they need to become? Are we going to see charging stations that look more like bank vaults? It started as a simple low-tech theft problem, but the solution might have to be very, very high-tech indeed.